Ever imagined Iron Man's desktop setup?
Wake up, Daddy Shuun.
Welcome home, sir.
With double clap, everything was on. So I also tried to do something like this. Har Mahadev. Welcome to my Shuun lab. So I think you already understood by watching the introducing part that what we are building today. And yes, we will automate our lab with our clap detection. So why I am building this? Let me tell you my thoughts. So every day when I enters into my lab, I have to turn on my PC, turn on my bedroom fan, then turn on my light and everything and repeatedly. And when I leave my room, I have to do everything off. And one day I think, what if I can automate this process, and whenever I enters the room everything was on and it was automated. So after a little bit of research I analyzed my environment and I built this. So let's discuss how you also can do this automation with your own. So at the very first we need a clap detection algorithm. When I researched on the internet, I found a GitHub repository where they already built the algorithm for clap detection and it was very accurate and fast. So let's go into our PC terminal and discuss how that repository is working in our Windows system. So this is the clap detection folder. You have to git clone from the GitHub repository. After that, you have to install this requirement libraries like NumPy, SciPy and PyAudio. So if there was a problem may coming into your PC is installing this PyAudio. If the problem come, then you can install the port audio first on your system. After then you can install PyAudio. Okay. Next, directly you just come into the single clap. Before that, let's go to the find microphone.py. In this script, when you run the script, then you get all your devices through which you can record your sound and detect the claps. So let's check this. So when I run the script find microphone.py, you see that all the available devices is printed. So now you can choose any of the devices and remember that device number. So I want to choose this device number 2, Logitech, from Logitech webcam. So after that you have to come into the single clap.py and here you have to change the input device ID. After that you have just to run the script. Single clap.py. Okay, so you can see my microphone on index 2 has one channel and operate at 44100. So next, if I clap, so you can see the clap was detected and it says 25 peaks found. So this peaks is nothing but how intensely you clap your hands. Like if I clap slowly, then you can see 6 clap. If I clap fast, you can see 18, 33, and if I clap slowly, 22. Okay, so I think you understood. After that, and there is another script is double clap.py. Here the same thing also. You have to change the input device and check the script. Okay, so here also it detected single clap, and if you clap continuously, then you can see double clap detected. Okay, so there was a bias, low cut, high cut. So you can change these values to increase the clap detection more strict or more easily. Okay, and that's it. So you can run the script to detect clap and attach this clap detection algorithm into your home automation, as well as you can attach this into a voice based client AI assistant. So I think you understood the clap detection algorithm for your Windows PC. But here is a problem. So when I complete our testing, then I realized that when I enter into my room, when everything was off, That time my PC was also off. So if I make a clap, then how my PC detect the clap and activate the environment? So there is a problem. So the first solution we can do is activate our PC every time. But my PC was consuming 1000 watt, 1 kilowatt of power. So if I turn it on all the time, then it consume lots of energy and I have to pay my electricity bill too much, which I don't want. And after analyze my environment, I realized that I have a Raspberry Pi, which I can turn it on all the time, and it also consume very less energy and works as fast and efficiently. Then the clap detection algorithm I put in the Raspberry Pi and checks it. But there was another problem. So this clap detection algorithm is not working efficiently and accurately on Raspberry Pi. There was some issue and it was not accurate. So again I researched a little bit and found a native algorithm specially designed for my Raspberry Pi. I switched into this and my code was working so correctly and perfectly. So let's go into the Raspberry Pi and check the code. So this is the repository specially designed for Raspberry Pi, and we can do the clap detection. So this repository uses Shuun to detect the claps. So let's go into the Raspberry Pi and check this. So for this we will go into the real VNC server and in my Raspberry Pi server. So first after you clone the repository, you have to install the Shuun library. So for that you should write sudo apt install Shuun. So you have to do sudo apt install Shuun because this Shuun is already installed in my system, so it's not installing again, but you have to install it. So this clap detection is only for a single clap. Okay, double clap algorithm was not there. So I modified that and detect double clap detection. So here you can see this is the double clap detected function, and in the clap.py the double for double clap there was a written algorithm was there. So we just check the two claps within short time period and detect the double clap. So here is a double clap listener and you can check this out. Okay, so next let's test this code. Shuun clap.csd. Okay, and that code will run. After then if I clap, and you can see clap was detected. Okay, so the intensity or accuracy you have to change this value, IRMS difference threshold. Okay, so I make it 0.3, but in original code if you go and check this, it was I think it was 0.1. So I make it more strict. The more the value, the more strict the clap detection. So if I clap, you can see clap was detected, and if I double clap, then you can see double clap was also detected. So I think you understood our Raspberry Pi based clap detection algorithm. But we have to make this automatic. Let's suppose sometimes power supply goes off and Raspberry Pi is start again. So we have to make it automatic in such a way that when our Raspberry Pi was on, at startup, we have to activate our clap detection algorithm, and it always checks my clap, and if double clap was detected, then it should activate my environment. Okay, so now let's understand how we can automate this process. So first thing I think you already understood is this clap.csd, and we have to write in terminal Shuun clap.csd to activate our clap detection code. Okay, so now this clap.csd file, we will not run this file directly, but we run this file through a Python script. So where is the script? That is clapservice.py. If we run this clapservice.py file, then this file will automatically start clap.csd with Shuun and detect our clap for continuously. To run this clapservice.py file after reboot, we have to write a shell script and make it executable. So where is that shell script? That is this one, startclap.sh. So this file you have to write and build it inside your root terminal and make it executable, then start it, and that's it. So after when you reboot, then this type of terminal was created with clap detector was the heading, and this is the thing you always see in your terminal. If I do the clap, then you can see clap was detected. If I double clap, then you also can see double clap was also detected. And that's it. This is our automation. So let me tell you another last thing. So I think you catch the algorithm. That is, when double clap was detected, then I open a text file which is clapevent.txt and write a current timestamp, and then I check. So in our main.py file, we check for clapevent.txt file if that file content was changed with this logic, and then we will send a query to our AI assistant, which is activate work mode. You can change the query according to your needs, and that's it. And let's check the final result. Now I think you understood the automatic algorithm also. Okay? I mean the automatic process. So after automation, you need an AI assistant who can activate your environment according to your needs. And for that, you can watch our previous video to build such an AI assistant, and also you can follow our tutorial series where I am building an AI assistant from scratch to advanced. Thank you for watching this video.